Video we'll be discussing about Mathematics Paper 4 Mechanics 2023 May June Variant is 43. The subject code is 9709. 1. Two particles P and Q of mass 0.1 kg and 0.4 kg respectively are free to move on a smooth horizontal plane. P is projected with a speed of 4 meter per second towards Q and Q is stationary. So P moves with a speed of 4 meter per second and Q is stationary, that means at rest. After P and Q collide, the speed of P and Q are equal. So the speed of P and Q are equal, but it is not given. So we can assume the speed as V. That is, both the speed is V. Find the two possible values of the speed of P after collision. So to find the speed, first of all, since only P is moving towards Q, so the first case would be that both are moving in the same direction, that is at this direction, or Q is moving in this direction, that is the initial direction of P, and P is moving in backwards direction. So these two are the cases, and for the first case, since both are moving in the same direction, that is in the positive direction, so none of the velocity is negative, and we can thus equate this, that is the momentum before collision is equal to momentum after collision, and we know that momentum is equal to mass into velocity. So the velocity comes to be 4 by 5 meter per second for the first case, and for the second case, as both are moving in opposite direction and Q is moving in the positive direction while P is moving in the negative direction from its initial direction, so momentum before collision is equal to momentum after collision, and we equate this to find the second velocity, that is 4 by 3 for the two cases. 2. A car of mass 1500 kg is towing a trailer of mass m kg. So this is our car and this is our trailer, that is m kg and 1500 kg. Along a straight horizontal road, the car and the trailer are connected by a tow bar which is horizontal. So this is the tow bar, that is light and rigid. There is a resistive force F on the car and a resistive force of 200 Newton on the trailer. So for this our car, the resistive force is F, and for the trailer, the resistive force is 200 Newton. The driving force on the car's engine is 3200 Newton. So the driving force, we have given the driving force, and the acceleration, that is the acceleration, and the tension in the tow bar is 300 Newton. That is, this value of tension and this value of tension is given. Find the value of M and the value of force. So we can easily calculate it by using the forward force minus backward force is equal to mass into acceleration. So for the car, the forward force is only the driving force minus the resistive force, that is the F force, and the tension force. So F and tension is equal to mass into acceleration. And for the trailer, the forward force is the tension force, that is the forward tension force, minus backward force, that is 200 Newton, is equal to mass into acceleration. After equating these two equations and substituting the values of acceleration, we get the value of M, that is 80 kg, and the value of force, that is 1025 Newton. We must give the unit, that is kg and Newton, for each of these quantities. 3. A smooth ring R of mass 0.2 kg. Now for this ring, that is this ring, we must write its mass or its weight, that is to 0.2 g, that is acting vertically downwards. Its weight is threaded to a light string ARB. So ARB. So this is basically our string, and as we can see that the string is free to rotate about the ring. That means the string can easily move around the ring and the string is not fixed about the ring. So the tension in this side of the string is same as the tension in this side of the string, that is T. The ends of the string is attached to a fixed point A and B, where A with A vertically above B. The string is taut and the angle ABR, that is angle ABR, is 90 degree, and the angle between the part AR of the string and the vertical is 60 degree, that is this angle is 60 degree. The ring is held in equilibrium by a force. So the ring is held in equilibrium. That means all the right force is equal to the left force and the up force is equal to the down force, since the ring is in equilibrium. That means there is no net resultant force by the force of magnitude x Newton, and this x Newton force is also acting on the ring in the direction perpendicular to AR. So this x Newton is perpendicular this AR. Calculate the tension in the string and the value of x. So we need to find the tension in the string and the value of this x. So for this tension and the x, we need to find its horizontal and the vertical component of forces. And since this angle is 60 degree, so this side is parallel to this side and this is a transversal. So this angle is same as this angle, that is 60 degree. Then this side is tan 60 degree, sorry, t cos 60 degree, and this is t sin 60 degree. Again for x, we know that this angle is 90 degree and this angle is 60, this is 90, so this angle is 30 degree. So this angle is 30 degree, this angle is 90 degree, and this is a horizontal line, so total angle is 180 degree. So 180 minus 30 minus 90, so we get our this angle as 60 degree, that is this angle is 60 degree and this is perpendicular, so this is 90, 60, 90, so 180 minus 60 minus 90, so we get our this angle as 30 degree. So basically this angle is 30 degree, so this side is x cos 30 and this is x sin 30. Then we need to equate the horizontal and the vertical component of forces. Since they are in equilibrium, so t is equal to t plus t sin 60 is equal to x sin 30. So after equating this equation, then again for the vertical forces, that is t cos 60 and x cos 60 is equal to 0.2 g, that is 0.2 g. After equating these equations, we get the first expression as this is our first expression and this is our second expression. Then we need to solve this simultaneously to find the value of x, that is 2, and the value of t, that is 4 minus 2 root 3, and we must include its unit, that is t is also a force, so Newton, and x is also a force, so its unit is Newton. So t 2 Newton and 4 minus 2 root 3 Newton. In question number 4, part A, the lorry of mass 1500 kg, that is this is our lorry and its mass is given, moves on a straight horizontal road in the direction from A to B, that is from A to point B. It passes A with a speed of 20 meter per second and B with a speed of 25 meter per second, respectively. The power of the lorry's engine is constant and there is a constant resistive force to the motion of magnitude 600 Newton. So the resistive force or the value of R is 6000 Newton. The acceleration of the lorry at B is 0.5 times the acceleration of the lorry at A. That means if the acceleration of the lorry at A is A, then the acceleration of the lorry at B would be 0.5 times that value. That means 0.5A or A by 2. That is A by 2. So this is the acceleration at point B, and at A the acceleration is A. Show that the power of the lorry's engine is this much. So we need to find the power and hence find the acceleration of the lorry when it is moving at 20 meter per second. So we have actually our acceleration, that is in terms of A, that is the acceleration at point A when speed is equal to 20 meter per second. So we need to now find the value of power and the acceleration. So first of all, at point A, since it is moving at a horizontal plane, so driving force minus resistive force is equal to mass into acceleration, and driving force is equal to power by velocity. And what is the value of power? So we actually need to find this value of power, but we know the velocity, that is 20 meter per second. So power by velocity minus resistive force, that is 600 Newton, is equal to mass into acceleration. So this is our first expression. And for the second expression, that is at point B, driving force minus resistive force is equal to mass into acceleration, and driving force is equal to power by velocity. We need to find the value of power, that is the same and constant power, that is the power is constant whether it is at point A or at B. The power P is the same. Power by velocity minus resistive force is equal to mass into acceleration. So after substituting the value, we get two of our equations. Then we equate this, that is power and power, to find the value of acceleration. Then substitute it, the value of acceleration, in any of this equation to find the power, that is 200 kilowatts. Thus shown. Body began to ascend a straight hill inclined at an angle of 1 degree to the horizontal. So this angle is 1 degree. It is given that the power of the Lorentz engine and the resistance force do not change. So the power and the resistance force do not change. Find the steady speed. So we need to find the steady speed up the hill that the lorry can maintain. So for the steady speed, that means the speed is constant. Since speed is constant, that means acceleration is equal to 0. So driving force minus resistive force is equal to mass into acceleration. That means acceleration is 0. Therefore driving force is equal to resistive force. So as it moves up the hill, so its weight is acting vertically downwards, and for its weight we need to find its horizontal and the vertical component of the forces. It is the horizontal and the vertical component of forces, and the angle is 1 degree, and the resistive force do not change, and we know that resistive force is 600 Newton. So we need to find the steady speed. So to find the value of steady speed, we have actually found our power. So driving force is equal to resistive force, and driving force is equal to power, that is 200 into 10 to the power 3 10 to the power 3 by velocity, and the velocity that we need to find is equal to resistive force, that is this value of resistive force plus this value of resistive force. After equating this, we get the value of velocity, that is the constant speed, as 23.2 meter per second. 5. Part A. A particle starts from rest from point O and moves in a straight line. The acceleration of the particle 10 seconds after leaving O is a meter per second square, where a is equal to k t to the power 1 by 2. This is the expression for acceleration for t is greater than or equal to 0 and less than or equal to 9. And where k is a constant, the velocity of the particle at t is equal to 9 is 1.8 meter per second. So at time t is equal to 9, we have given the value of velocity. Show that the k is equal to this value, that is 0.1. So to find the value of k, we know the value of time and the value of velocity. So as we know the value of velocity at the time, so we can just integrate acceleration with respect to time to find an expression for velocity. So after integrating, we get an expression of velocity in terms of c, and we know that at rest, that means at time t is equal to 0, velocity is 0, so the value of c is also 0 after calculating. Then we get the expression of v. Then in the expression of v, we need to just substitute the value of t and the v to find the value of k. So after substituting the value of t and v, we get the value of k as 1 by 10 or 0.1 as shown. That is given in the question. Then in question number 5 part B, for time t is greater than 9 and the velocity v meter per second of the particle is given by the expression. So this is for t is greater than 9. In part B, show that the distance moved in the first 9 seconds is 1/10 distance moved between 9 to 18 seconds. So basically we need to find the distance for both the two intervals. So for the first interval, that is 0 to 9 seconds, what is the value of distance? So we know the expression for velocity and we know the value of k. So after substituting the value of k in this expression of velocity, that we have found that this expression of velocity, we need to substitute the value of k to find an expression for velocity. And as we know the expression for velocity, we can just integrate velocity with respect to 9 and 0 to find the distance in the first 9 seconds, that is from 0 to 9 seconds. Then again we have given that for t greater than 9 seconds, we have given another expression for velocity. We need to just integrate this expression of velocity with respect to 9, and the highest value of t is 18, so 18 to 9, and after integrating velocity we get an expression for displacement, and after substituting the value we get the displacement as 64.8 meter. So we need to express that the distance in the first 9 seconds is 1/10. So we need to divide this value by this value, and after dividing, that is 6.48 by 64.8. After dividing, we know that the distance is 1/10. So this is shown. Part C. Find the greatest acceleration of the particle during the first 10 seconds of motion. So for the first 10 seconds, we need to find the greatest acceleration. So in the first equation of acceleration, we know that this equation is satisfied from time t is equal to 0 to time t is equal to 9 seconds. So for time t is equal to 0, we need to find a value of acceleration, and for t is equal to 9, we need to find a value of acceleration. Then again, we have given another equation for velocity. So for this equation of velocity, we need to find the acceleration, equation of acceleration. Then when t is equal to 10, we need to find the acceleration. Then we have to choose which acceleration value, that this value, or this value, which value is the greatest. So to find the greatest acceleration, we can see that the last acceleration value, that is 0.4, is the greatest when time t is equal to 10. So the answer would be 0.4 as our final answer. In question number 6, part A, an elevator is pulled vertically upwards by a cable. The elevator accelerates at 0.4 meter per second square for 5 seconds. So for 5 seconds it accelerates and then travels at a constant speed for 25 seconds. So it accelerates and then comes to a point. Then again it moves at a constant speed. The elevator then decelerates at 0.2 meter per second square until it comes to rest. So it then decelerates until it comes to rest. Find the greatest speed of the elevator. So the greatest speed is when it comes to the maximum point. So that is v is equal to u plus at. So v is equal to u plus at. So we know that initially it was at rest, since the elevator does not pull it. So initially it is at rest plus at. So this is the acceleration and this is the value of time. So we substitute this value in our equation and get the velocity as 2 meter per second. That is our highest velocity. Then hence draw a velocity time graph for the motion of the elevator. So this is a velocity time graph, velocity against time, and for the motion of the elevator. Elevator accelerates until it comes to a maximum point, then moves at a constant speed, then it decelerates and comes to rest. And for the time interval, that is, it accelerates for 5 seconds, then it moves at a constant speed for 25 seconds. That means acceleration time plus constant speed time, in total the time is 30 seconds. Then as it decelerates and comes to rest, so we know that the value of deceleration, that is the negative acceleration, and it comes to rest, so final velocity is 0 and initial velocity is 2 meter per second. So initial is 2 meter per second. After substituting this in our equation, that is v is equal to u plus at, we can find the time of deceleration. As we know the time of deceleration, so this is the time of deceleration and this is the time for constant speed, or the total time. So we add this and find the total time after deceleration is 40 seconds. So after 30 seconds it decelerates at time t is equal to 40 seconds. It comes to rest. 6, part B, find the total distance traveled by the elevator. So what is the total distance? So we have initially drawn a velocity time graph, and the distance is the area under the velocity time graph. So this area under the velocity time graph is the total distance or the total displacement. That is, the total displacement would be half into sum of two parallel sides, that is 40, and 30 minus 5 into height. So half into 40, sum of two parallel sides, that is 40, plus 30 minus 5, that is 25. So these two parallel sides into height of 2. So the distance comes to be 65 meter as our answer. Then in part C, the mass of the elevator is 1200 kg. So this is our elevator and this is the object inside the elevator, that is the crate, and their crate of mass m kg. So the crate has a mass of m kg and the elevator has a mass of 1200 kg. Resting on the floor of the elevator. Given that the tension in the cable when the elevator is decelerating is this much. So initially the elevator is moving upwards and the tension in the cable is this much. Find the value of m. So to find the value of m, we can use the forward force minus backward force is equal to mass into acceleration. So forward force is this value, that is this source, minus backward force, that is mass into gravitational field strength. So total mass is 1200 plus m into gravitational field strength. So the forward force minus backward force is equal to mass into acceleration, and since it is decelerating, so our deceleration value is 0.2. As we can see that here our deceleration value is 0.2. So the acceleration would be negative 0.2. So mass into acceleration, after solving this, we get the mass, that is 50 kg, as the mass of the crate. Find the greatest magnitude of force exerted on the crate by the floor of the elevator and state the direction. So this is a quite lengthy question, and if you think of, then this basically refers to the movement of the crate and the elevator, and for each of these parts we need to find which force is the greatest magnitude of force. So first of all, when acceleration occurs, then forward force, that is it is moving upward, and acceleration occurs, so forward force minus backward force, that is the forward force exerted by the elevator. So forward force minus backward force is equal to mass into acceleration. As we can see that if we equate this, then this 50 gram is 50 g is the gravitational field strength, 50 g gravitational field strength is added with this value. That means this would give a largest value of force. And for this part, as we can see that it is moving at a constant speed, that means a constant velocity, that means driving force is equal to resistive force. Driving force is equal to resistive force. So for this situation, we know that the driving force is R, that is the forward force. So driving force is equal to resistive force, that is 50 G. So if we equate this, then we can see that the maximum magnitude of force is 50 G, but here we can see, or 50 G or 500 Newton, but here we can see that it is 520 Newton. And for the third part, that means for the third situation, when it is decelerating, its deceleration value is 0.2, so acceleration is negative 0.2. So for this situation, forward force, that is the upward force, minus downward force is equal to mass into acceleration. After equating, we can see that this, I just write it here, 50 into negative 0.2 is added with a 500. So as we can see that the answer we get is less than 500, that is approximately 490. So in all these situations, when the car is accelerating 520, when the elevator is accelerating 520, when the elevator is moving at a constant speed 500 Newton, and when it is decelerating, the force is 490 Newton. So in all these cases, we can see that when it is accelerating, the value of forward force, that is the force by the elevator, is greatest. So the greatest magnitude of force when acceleration occurs, and the acceleration value is 0.4 as given in the question. So the greatest value of force is 520 Newton, and it is acting upwards. Since this is the force by the elevator, so the force is obviously acting upward. Number 7. The diagram shows the vertical cross section XYZ, that is X, Y and Z, this surface of rough slide. So the slide is rough, that means there is an effect of friction, that is mu r. The section YZ, that is this slide, is a straight line of length 2 meter, is inclined at an angle of alpha to the horizontal, where sin alpha is given. So we know that sin alpha is this value. The section YZ is a tangential to the curve XY at Y. So basically this statement states that this is, suppose XY is a curve and this is a tangent to the curve, but this statement is unnecessary right now, or we do not need this statement right now. Okay, tangential to the curve at Y, and X is 1.8 meter above the level Y. So X is 1.8 meter above level Y, that is 1.8 meter. A child of mass 25 kg slides down the slide starting from rest at Y. So the child starts from point Y. The child starts from point X, that is this point, and its mass is given, that is 25, and so its weight is 25 g, that is acting vertically downwards. So for this plane, we need to find its horizontal and the vertical component of forces. So this is the vertical component and this is the horizontal component. This is 25 g sine theta, and the work done by the child against resistance force in moving from X to Y is this value. So work done against resistance, that is WR, is 50 joules. 7 part A. Find the speed of the child at y. So we need to find the speed of the particle or the child at y, and the child is represented by this 0, that is this 0. Okay, so to find the speed at y, first of all, if we consider this base, then at this height, that is this value is the height from the base. So at this point, the gravitational potential energy is equal to the kinetic energy at this point plus work done against resistance at this point. Since at this point it is at rest, it is already mentioned in the question that it is at rest at x. So at point x it is at rest, that means velocity is 0, so kinetic energy is 0. So at x there is only gravitational potential energy, that is gravitational potential energy, and at y, since there is an work done against resistance, that is 50 joules, and kinetic energy, that is the kinetic energy at y, and we need to find the speed of the particle or the child at y, that is v. So gravitational distance is equal to mass into gravitational distance into height, that is if we consider this as a base, then the height from this base is 1.8 meter, is equal to kinetic energy, that is half mv square, plus work done against resistance. So the velocity that we get is 4√2 meter per second. P, it is given that the child comes to rest at z. That means at point z, the velocity is 0 since it comes to rest. Use an energy method, that means we have to use the work energy relationship to find the coefficient of friction, that is the value of mu, between the child and yz, that is between the child and this surface, that is yg. Giving your answer as a fraction, so we must give our answer as a fraction and not in decimal in the simplest form. So if we compare, then the gravitational potential energy at this point, if we consider this as a base, that means there is some vertical height, so this height, and so the gravitational potential energy at this point, plus we know that there is a speed at this point, that is the speed at y, so kinetic energy at this point is equal to, there is ep at y plus ek at y is equal to, at this point since it comes to rest, therefore the kinetic energy is 0, and since it is the baseline, so obviously the gravitational potential energy is 0 since there is no vertical height, so there is only work done against resistance. So this energy is equal to work done against resistance. So to find the gravitational potential energy, that is gravitational potential at y plus kinetic energy at y is equal to work done against resistance as z or z. So gravitational potential energy is equal to mass into gravitational force into height. So what is the value of height? We need to find this value of height, that is this vertical height h. So to find the value of h, we know that this side, and we know that sine alpha, so we know the value of sine alpha, so sine alpha is equal to this value, so we replace sine alpha with this value, that is 0.28. Sine alpha is equal to opposite by hypotenuse, so opposite is h and the hypotenuse is 2 meter, that is this length. So sine alpha, that is this angle, is equal to opposite by hypotenuse, so the height comes to be 0.56, that is this height is 0.56 meter. So the gravitational potential energy is equal to mass into gravitational force into this height, and the kinetic energy at y is half mv square, where the velocity is 4√2. So this is the height for gravitational potential energy, and 4√2 is for kinetic energy speed, is equal to work done against resistive force, and work done against resistive force is equal to force into distance, and the distance or the length of the slide is this 2 meter. After equating this, we get the frictional force, that is 270 Newton, and frictional force is equal to mu r. So what is the value of r? This is the object and this is the downward force, and r is the vertically upward force. So downward force is equal to upward force, that is downward force is equal to 25 g cos theta. So upward force is equal to r is equal to 25 g cos theta, since upward is equal to downward force. So the value of r is 25 g cos theta. After substituting the value, we get the value of mu, that is 9/8.